All right, I am going to do the notes for the second set. I think I screwed up, you guys. I said the other ones were the second, the one that are going to do tomorrow. So anyway, whatever. These are the second set of notes. This has to do with interest. Let me make sure. So a couple of things before we begin, just in case you don't know, interest can either be charged or you can earn interest. So for example, when you take out a loan, they might charge you a certain percentage interest so that, like if they charge you, say, 10% interest, say like you take out a loan for $1,000 and they charge you 10%. Say you paid nothing on that loan and this is 10% annually, okay, annually. Then the next year you would owe 1,000 plus 10% of 1,000, which is $10, yeah? 10%, $100. $100. So you would owe 1,100. So the idea of interest is that it's a percentage that they charge you or that you earn. Okay, so we use, oh, hang on, I don't want to erase anything here. Let me see. No, I did it. Okay, let's try this again. Come on. I'm doing Control Z, peeps. Oh, come on. Not doing it. There it goes. Okay, I'm going to lock this down. Lock it all. Okay. All right. So I'm going to teach it a specific way. Alex tends to teach you a lot of different case scenarios, like simple interest compounded, whatever. And then they show you a few different equations. I'm going to show you a couple different equations. Okay, so I want you to take these down. I'm going to write the notes here because I have them here. Okay, so this is going to be called compound interest. Okay. The reason why I want to do this is because I want you to have one formula that will serve you in all cases. This is the most complex formula, but it works for simple stuff too. So it's A is equal to P times 1 plus, and oh my God, hang on a second. 1 plus R over N to the NT. Okay, and let me tell you what each of these letters is. P equals the principal. If you want to, you can think of this as the initial amount. It's the easiest way to think about it. It's what you started with. All right, R is the rate, percentage rate. Okay, it's always in decimals. So you convert the percentage rate to decimals. N is equal to the number of times, usually per year. I'm going to say per year because that's the way it typically is. And again, N happens here and here. And then T is the number of years. Could it change? It could possibly change if they decided to do it in other like time values, but typically it's years. Okay, that's compound interest. That's the first one you want to make sure you have down. What is A? A stands for amount, and it means the final amount. Okay, so final amount is equal to the principal times the quantity, 1 plus the interest rate divided by the number of times per year to the, okay, number of times per year times time. All right. As long as you have this down, you will be fine. Copy this down, make sure you have it for reference, okay? The other one that I want you to copy down is the one that's going to happen with E. Okay, this is for interest that is compounded continuously. Okay? And this uses E. So it's the PERT formula, E to the RT, where P, wait, I'm sorry, I did that wrong. A is equal to P, my bad. The final amount is equal to the principal times E to the RT. Everything is the same. A is the final amount. T is the number of years. E is E. R is the rate and interest, and P is the principal. Same letters, but the only difference is we're going to use natural exponent, E. Okay? All right. And then the final equation I want you to write down is the exponential equation. Y is equal to, and I'll do this, okay? Y is equal to A times B to the X. Now, to be honest with you, this can get way more complicated. I don't think we're going to hit it. Do you know how you can move it horizontally and vertically? Okay, it could literally be like this. So A is going to move the graph, like it's going to make it go either like, or, okay, A changes the not the slope, but kind of that speed of the exponential equation. Okay, B is the base, X is the exponent. Okay, for the most part, I don't think you're going to need to write down the H and the K. I just wanted to show you that, but I don't think we're going to need it. I think we're just mainly going to be using here. So here's what you need to know. A is what we start with, starting value. And B is the base, or this is going to be, basically, it's the rate, okay? And it's going to be the positive rate. I'll explain what I mean in a bit with that. And X is usually going to be time, to be honest. Okay, so it's AB to the T. I'll actually even change that. T is going to be time, okay? And it could be various amounts of time. Sometimes it's time in years, sometimes it's in months. It just depends on what they ask you, okay? So T is time. All right, so the reason, check this out. The reason why A is the starting rate is because, look, if time is 0, like we just started, like we're just taking off, time is 0, we haven't done anything yet. B to the 0 power is equal to 1, right? And that would be A. 1 times A is A. That's why that's our starting rate. All right, so now I'm going to erase all of this. So make sure you got it copied down, because I'm going to erase it all because I need this space to do this problem, okay? So the very first ones, like I said, they're pretty simple, and the way Alex explains them is going to be different than the way I explain it. I'm going to use the formula because I feel like it's just something that is easy, something you can grab when you need. Wow, I should have really just got another page here, huh? Oh well, whatever. Okay, here we go. Almost done. Okay, there we go. Boom. All right, so here we go. I'm gonna get black, I think. Okay. Okay. So it says suppose Rita places $2,500 in an account that pays 14%. I'm sorry. What kind of problems are these? 14%. There's hardly anything that would pay that. Maybe some crazy stock market thing. 14%. Banks pay like 0.01 now. It's so stupid. Anyway, okay, it pays 14%. Let's imagine. Okay, assume no withdrawals are made from the account. So she deposits it, right? She wants to make 14%. Follow the instructions below. Do not do any rounding. Find the amount of the account at the end of 1 year. So simply enough, you're just basically, look, you put in 2,500, and then that next year you earn 14% on that 2,500, and you would add this. That's the simplest way to do that, okay? And if you were to do 2 years, you would take this amount and then multiply that by 14. Okay, I'm going to show you how to use the A is equal to P times 1 plus R over N to the NT. And like I said, for me, it's just so that you have something to just fall back on. So here, what's the principal? Principal, 2,500. What's the rate? 0.14. Okay. What's the time? It's compounded at the end of the year. That's yearly, once a year. So time is 1. And N is 1 because it's compounded yearly. Let's get this straight, you guys. The words matter real quick. Yearly means once a year. Biannually means 2. This is N. Okay, quarterly. That means every quarter, that's 4, because there are 4 quarters in a year. Okay, monthly, N would be 12. Daily, N would be 365. It is 0.25 because there's 0.2, whatever, but basically you would probably round it to 365 unless they tell you to use 365.25. Get the idea? That's what N is. And in this case, N is once because it's compounded once a year. All right, so you can see how this is going to get super simplified. And that's okay. I don't care that it's simple. It doesn't bother me. So what? At least you have something to always fall back on. 2,500 is your P. 1 plus R, 0.14 divided by 1 to the NT. N is 1, T is 1. See how that's just 1? So see how it actually is this exact thing? It's 2,500 times 1. Look, 2,500 times 1 is 2,500 plus 2,500 times 0.14. They're both the same equation, just written slightly differently. Okay, and then you plug that into your calculator. It's that simple. 2,500 times 1 plus 1,4. So it's 2,500 times 1.14. 2850. So at the end of 1 year, you would have 2850. You would have made $350. Boy, that's like a dream account. How about 2 years? So you could come back here to this equation. It's still once a year, okay? N is still 1, but then we are going to change it to 2. Now it's 2 for this one, okay? So that's squared. So now it's 25 times 1.14 squared. So 2,500 times 1.14 squared, 3249. Okay, so you would have 3249. Okay, that makes sense. See, it went up another year. And if you look at the way that they've explained it, they do this. They go, okay, so this is year 1. This is the interest you make because you're taking 14% of 2,500. And then this amount is what you will multiply the next year by 0.14. Correct? So that's where the squared comes into play. All right, working on that, moving on. Okay, let's look at the next problem. So it says finding the final amount in a word problem, exponential growth or decay. So now we're talking about exponential growth or decay. What I want you to do is think about if it deals with money, okay, typically you're going to be using the A equals whatever, okay, formulas. Okay, if it deals with anything else like that, like, I don't know, like half-lives of molecules, then you'll be using the y is equal to AB to the x. Okay, there's times when you could use this. I just don't want to explain that. Okay, so I would just prefer to use that one formula. So here we go. Ready? It says 2,300 is the principal, so P equals 2,300. 3.5 interest, R 0.035. Compounded annually, so N is 1 time a year. 10 years, T is 10. So all you have to do is plug it into the formula. That's what's fun about this too, is that you just have to plug it in to the 10. And that's it. This becomes 2,300, times 1.035, because you add these to the 10th power. Okay? When you plug it into the calculator, you can plug it in that way. Wait, what is it? Sorry. It's 2,300 times 1.035. 2,300 times 1.035 to the 10. equals 3,244.37. I don't know what they want you to round it off to, so let's check it out. 324437. 324447. Okay, that's smaller than 5, so it's 3244. They said nearest dollar. Okay, take a look at the next one. It might be too small. Sorry about that, you guys. Okay, again, if you want to try it on your own, go ahead and pause and then check it with me. Then you can zoom through me. So the P is 1800. Rate is 0.06. Compounded annually, so N is 1. 15 years. A equals 1800 times 1 plus 0.06 to the 15. I didn't multiply or divide by 1 because I don't need to. A equals 1800 times 1.06 to the 15. There you go. 4,313, and then round it up. So 4,314. Okay. How much is it worth after 15 years? So again, we're still answering this. Sometimes they ask you how much did you earn in interest, which is totally different because that would be 4,314 minus 1,800, right? We're talking about what you earned over what you initially invested, but that's not what this problem is. I just want you to make sure you're paying attention to what they're asking for. All right, finding the final amount in a word problem on compound interest. David deposited 4,000 into account with 4.2 interest. Compounded annually, assuming no withdrawals are made, 3 years. T equals 3. Do not round any intermediate computations, and then round your answer to the nearest penny, nearest cent. When they say don't round any intermediate computations, because you're plugging it in like this, sometimes people are wanting to do this. Well, it doesn't make any sense actually, but let's say this were like 12. They would do this piece first and then round it and then add it to 1. You don't want to do that. You literally want to keep it as clean as possible and enter in the calculator value or the calculator numbers, okay? I'm not going to actually do that because I've been doing it and I don't think that's a problem. Just round off to the nearest cent, which is the nearest hundredth, okay? Next, I'll help you set this one up, okay? Take a look. It says Henry deposited 4,000 or 40,000. 1, 2, 3, 4,000. So P equals 4,000. Rate is 0.05. Compounded semi-annually. So now N is 2. Assuming no withdrawals, 10 years. Okay? So watch. You're going to plug this in. And then you need to divide this by 2 and then go to 10. But they don't want you to do this. Do not round any intermediate. So you could do this and then not round, but just plug that into the calculator. It's much easier. So it's 4,000 times, okay, put the parentheses, right? 1 plus 0.05 divided by 2. 0.05 divided by 2. See, it knows the order of operations. It will do that first. All of that to the 10. 5,120.34. Nearest cent. 5,120.34. So round to the nearest cent. There you go. But do you see how I entered it into the calculator? You don't have to do all the intermediary stuff if you know how to enter it into the calculator, and it makes it so much easier. All right, so now we're getting into the y is equal to the a. I'm trying to make this bigger. Hang on a second. It's not going. There it goes. Okay, y is equal to the a b to the x. Or in this case, v of t, which means v, dollar value. The value is dependent on time. And then this is a, and this is b, and this is t. Okay. Find the initial value. So what they want you to know is which of these numbers of letters or values is the initial. A is the initial, because if time is 0, A is the initial amount. So it's 239,900. That's all. Does the function represent growth or decay? Okay, take a look at this. Do you see how it's less than 1? Okay, that means it is shrinking. So if it's greater than 1, it's going to be growth. Okay, and that's if the base is greater than 1. I probably should put that. If B is greater than 1, it's going to be growth because we're increasing. We're more than 1. If B is less than 1, it is decay. Okay, and it makes no sense for it to be equal to 1 because then it's just the initial amount and it stays the same. So that makes no sense. Okay, does the function represent growth or decay? Decay, because that's less than 1. So you're taking 85% of it each time. Each time it's decreasing by 15%. Do you guys get that? This is decreasing by 15% because it's taking 85% of it each time, each t. Okay. By what percent does the value of the house change each year? So I want to say that the value decreases by 15%. And I think that's what it is. I'm not sure if by what percent does the value change each year? I feel like it's 15%. We're changing it by 15%. We're taking 85% of it, but we're dropping it down 15. Okay. All right. And I don't think you put negative 15. I think you just have to put 15. I'm not sure how they do it. It should be negative 15, but I don't know. Finding the initial amount and rate of change given an exponential function. Same problem. Okay. What is the initial value of the car? 27,500. Does it represent growth or decay? Check this out. Okay. Wow. This guy increases. Okay, what kind of car increases with time? It has to be a classic or something. This is growth because it's over 1. So it's increasing that 1. Think of this at 1.24 as 1 plus 0.24. Like, think of it as like distributive property, 27,500. So we're doing 27,500 plus 24% of that. Okay. All right. It says by what percent does the value of the car change each year? 24%. And it's a positive 24%. I don't know if they want you to name the positive or negative, you guys. All right. Writing an equation that models growth or decay. So now you need to start knowing what you're doing. So this is y is equal to a initial amount base rate to the time. Principal of 3,000. Okay, that's your initial amount. Was invested at 6.25. Okay, wait, hang on a second. 6.25 interest. Ooh, this is money. Money. Okay, I'm going to try to do it with the exponential form, and then I'm going to do it with the A form. Okay, compounded annually. So n is equal to 1, which means in this case, it's totally fine to let t be years because it's every year. So that means t is every year. And interest rate, it's going to increase at 6.25. That means you would go 1. Okay. In other words, it's going up 0.0625. But we have to multiply that by 1. So it's 1 plus 0.0625 to the t. Let y be the investment in dollars and write an exponential function showing the relationship between y and t. So this is how you do it with the exponential equation. If you understand it, go for it. Okay, that's just saying that this is an increase. See, increase. So you could also do it with this. Okay, so look, P 3000, 1 plus 0.0625 divided by n, which is annually, so 1 to the t. N is 1. This is 1 and 1. It just makes it simplified. A equals 3000 times 1.0625 to the t. See, you get the same exact thing, you just change that to y. So let's take a look at the next one. You can take your time if you want and pause the video. Okay, same thing here. Okay, so we go A equals P times 1 plus R over N to the NT, or we can go Y is equal to AB to the T. This is the initial amount and the rate. Okay, so let's try this. Let's do it quicker. This is the quickest way. Y is equal to 2200 times its increase. They're paying them. So it's 1.0525 to the T. Okay, you could also do it here. P 2200, 1 plus 0.0525 over N, which is 1, to the 1 times T, which is just T. And you get the same exact answer. Change this to Y because they tell you A is Y. Y is the value. Okay. I just don't want you to be scared of these. They're not that scary. Okay. In this question here, this is naming the asymptote, okay, of a log equation. Okay. So this is what a log equation looks like, you guys. Exponential looks like this, right? Or, right? Logs look like this, okay? Basically, if you imagine them being reflected over the x-axis, it kind of looks like that, okay? It actually goes like this. Like this is the XY axis, you guys. The logs actually come up above. It looks like this. If this one comes down like this is the exponential function. Let me go ahead and erase this. Okay. If this is the exponential function, it goes right here, and then it goes. The log function is the inverse. So it comes up here, and then it goes like this. You can imagine that it's kind of being reflected over the y equals x axis. All right. This is a log equation. And what it's telling you is that something is going to be increasing, and then it just will never be able to reach it. Do you see this dotted line here at 200? That is an asymptote. An asymptote, I don't know, have we had asymptotes? This is how you spell it, asymptote. It will never reach it. It will approach, but never reach. Okay, it says a company made a change in advertising. Suppose the company's monthly revenue in thousands of dollars, X months, after the change can be modeled in an exponential function. Okay, the graph of this function is shown below. Okay, this is weird. This is exponential. Looks loggy. Okay, what is the y-intercept of this graph? Basically, it's still just reading the graph, and it's 50. See, it's right there. The y-intercept represents what? Basically, it's where you start. It's your starting amount, right? Since the company's monthly revenue in thousands of dollars, X months. So this is your starting. We haven't had anything. Okay. Company made supposedly revenue thousands of dollars. So this is 50,000. Make sure you understand that. 50,000. Even though it says 50, it says in thousands of dollars. That means 50,000. Okay. All right. For the first 10 months, as time increases, the monthly revenue increases rapidly. Check it out. It increases very rapidly. Okay. In fact, if you look here, this could probably be 1 right here. And if you look at the slope of this line, it went up 100, like 50,000, from 50 to 100, 50,000 in maybe 1 year or 1 and something years. All right. Give the equation of the asymptote. Y is equal to 200. Okay. Choose the statement that best describes the meaning. Okay. The company will only stay in business for 20 months. No. Remember, this is money. 200 translates $200,000. The company's monthly revenue does not rise above $200,000 per month. There you go. It's never going to go above $200,000 per month. Okay, let's try this one. Is this the same one? No, but it's similar. So take a look. Okay, this is about an oven that's being heated. So the oven will never get past 250 degrees Celsius, which is pretty dang hot. Okay, so an oven is being preheated. As the oven heats up, its temperature in Celsius after X minutes, so time is your X, exponential function. What is the initial temperature of the oven? Right there, 50. Okay, the initial temperature is represented by the y-intercept. Okay, for the first 10 minutes, right here, as time increases, it's time, the temperature increases rapidly. Most likely that's what it's going to be, because look, it increases. Okay, and then it starts to flatten out after 10 minutes. Give the equation of the asymptote. Y is equal to 250. Choose the statement that best describes the meaning of the asymptote. The temperature oven does not fall below 50 degrees centigrade. Nope. The temperature of the oven does not rise above 250 degrees Celsius. Okay? It just shows you it'll approach it but never reach it. And that's the end of these notes.